So next part, which is integration type 6, is actually very similar to type 5. Okay, just that, okay, there's no more square root at the denominator over here. Okay, so if you look at here, same thing, we learn how to differentiate tangent inverse. Of course, integrating back, it will give me tangent inverse as well. Okay, so take note, the second column here is in your MF26. However, here is not in your MF26. Okay, so you somehow rather need to derive from the MF26 formula. Okay, another thing to take note, okay, if it's the ln here, if you look at MF26 under the integration portion, okay, all the ln doesn't have a modulus. However, almost every single modulus you have to include, or rather every single ln, sorry, have to include the modulus here. Okay, the reason why they did not include in your MF26, okay, is because they actually denote the range of x, okay, such that your fx, your x, or rather your ln fx will always be positive. However, we don't denote the range when we do integration, so we need to make sure that we always include the modulus. Unless, of course, okay, your a plus x over a minus x, etc. is always positive, then we don't include modulus. Okay, but to make it safe, generally I'll just leave the modulus there, such that I don't get any careless mistake over here. Okay, so same thing, I'm going to run through with you the method here. Okay, so I can't actually use f prime x formula. Okay, so take note, okay, we cannot use integrate of f prime x over fx formula. Okay, you should know that this will give you ln modulus fx. Okay, reason being is because the numerator doesn't have f prime x. Okay, so we have to somehow or rather relate back to this formula over here. Okay, so I'm going to run through with you a different kind of formulas here, such that it will be a lot easier for me to do. Okay, so first here, realize that my denominator is in terms of a quadratic factor, so I need to do a quick completing the square. Okay, so I will skip the completing the square parts. Okay, I'm going to write straight the answer. So x squared plus 4x plus 9 should give you x plus 2 squared plus 5. Okay, if you don't remember completing the square, please do a recap with yours completing the square as well. So when I integrate 1 over x squared plus 4x plus 9, essentially, once I do a completing the square, I should derive this. Okay, and if you look at these three formula, I'm actually looking at the first formula, which is integrate of 1 over a squared plus x squared, or rather now it's in terms of fx squared plus x squared, but doesn't matter, so long you apply the formula correctly. This should give you, sorry, it's 1 over a. Okay, don't forget the 1 over a. Okay, take note your a here is actually square root 5. Okay, so I will have 1 over root 5 tangent inverse x plus 2 over root 5 plus c. Okay, this is the first formula, or rather first answer. Okay, same thing, if you do a quick one for part 2, okay, if you do a completing the square, it should give you x plus 3 square. Okay, quick calculation, it should give you minus 29. Okay, so if you put into integration format, okay, integrate of 1 over x squared plus 6x minus 20, this will actually give me integrate of 1 over x plus 3 square minus 29 dx. Okay, take note, this is actually the second formula. Okay, x squared minus a squared, or rather fx minus a squared. So your fx is x plus 3, so f prime x is 1. So there's no need for me to introduce any constant outside. Okay, so I can plug in the formula straight. Okay, it's 1 over 2a. So in this case, your a is square root 29. Okay, ln modulus x plus 3 minus square root 29 over x plus 3 plus square root 29 modulus plus c. Okay, so a few common mistakes that you have to take note is that a lot of students forget to root it. Okay, another thing is forget about the modulus. Okay, so these are the small things that you need to take note. Okay, next page have a few more answers for you to try. I'm not going to work out the solution, but I'm going to give you the final answer such that you can actually derive the answer on your own. Okay, so if you can't derive, same thing, if you are my student, feel free to reach out to me, okay, and check where you actually go wrong. Okay, if not, these are the final answer. Okay, I'm going to leave the manipulation of the working to you. Okay, this and the part 2 answer will then be 1 over 2 root 11 ln plus c. Okay, so I'm going to leave these two final answer. Please do and go and work out the solution yourself. Okay, an extra part for you all. Okay, so we have learned a fair bit of standard integration of type 6, type 5, which is all about sine inverse, and type 4, which is actually partial fraction. Okay, so sometimes, okay, where we actually can come across, I can use two different kind of formula. Okay, so for example, questions like this. Integrate of 1 over x plus 3, x minus 2. Okay, there's two methods. Okay, one, we can straight away put into partial fraction. Okay, and go ahead and integrate accordingly. Okay, another one where we actually can expand out. Okay, then we do completing the square. Okay, then after that we use our MF26 long formula from the integration portion. Okay, both methods will eventually still derive the same answer. Okay, if not, don't believe you can go ahead and try both methods. It should derive the same answer as well. So which method is actually easier? Generally, I will actually prefer to do the second method, which is expand and do a completing square. However, this will only work if the denominator is a quadratic factor and is able to factorize. If not, if you actually go back to look at our partial fraction portion, okay, certain questions are totally not able to use the completing the square formula and then use the formula according to MF26. So unfortunately, we still have to learn the partial fraction method as well.